In this discussion, we're going to talk about controlling bias. Well, we're going to at least talk about the types of bias that there are, types of error. Error is error in systematic, or bias is systematic error. It's it's what keeps us from getting at the real underlying truth. There's four types we're going to talk about. Coverage, which is basically, are you sampling everybody that you think you're sampling or that you want to sample in a particular area. There's sampling error, which is what you usually think of when you see a survey. So X number of people prefer one candidate, plus or minus 3 percentage points, that sort of thing. A non-response bias or error, which is caused by people who don't respond to your survey, who don't return it or don't fill it out. What's the difference between them and those that do? Measurement error, that's when you ask a question that either is not consistent across people, or it could measure something not quite correct. So first, let's talk about coverage. A failure to enumerate. So there's an old example. Literary Digest a while back predicted Alf Landon would emerge victorious over Franklin Roosevelt, 55% to 41%. Now they came to this conclusion because they mailed out ballots to 10 million people, and they sampled those people from telephone directories. 36% of the people had phones at the time, and they got a 20% response rate. They had 2.3 million ballots returned to them. This turns out to have given them a really accurate estimate of the wrong number. Roosevelt won 61 to 37%. So the problem is that the coverage was just incorrect. 36% of the people having phones, 20% of those responding. It was no way representative of the voting population. Also consider all the surveys in the 2016 presidential election. I mean, there's a great example of coverage error. You just didn't get the people that were Trump voters in these surveys. People just didn't answer them. They're very hard to, that information is very hard to collect. And so people just didn't have the right estimates. So how will you assure everyone is sampled? You need a list of available subjects, respondents. You need, if you're going to do a job satisfaction, you need to have a list of your employees and make sure every employee has an equal opportunity to be part of the survey. If you're going to do alumni, there you run into problems because addresses are not kept up. So this is an issue to assure that if you capture someone in the survey and the survey is returned because the address is unknown, you have to do a little extra work to dig it out. You don't just go get another alumni person to take the place of the one that didn't return it or you didn't have the answer to. You go try and get it. There are systematic reasons people move to different and don't leave forwarding addresses, or they've moved so many times the forwarding address is lost. When you don't survey schools in Oregon, if you want to look at students, but you look at students within schools. And so in order to get a representative sample of schools, or to get a representative sample of students, you can sample schools through some systematic way of urban people. In Oregon, for example, Portland is a big city, but all the other cities are not all that big. And the schools are very different. There's a very different type of person in a poor school in Portland versus a poor school in some other rural eastern part of Oregon. They're both poor, but their population is very different. I had to do a health clinic survey on women, and I chose young mothers, and I was able to get a pretty good list from birth certificates, from county birth certificates. They list the address of the mom. And so I surveyed new mothers whose children had just been born in the previous year. So the addresses were still pretty good. And new mothers are motivated to respond to health surveys. So that was a pretty good, successful survey. In general, if you don't have a list, you cannot use the internet as a viable alternative to a probability sample. You can't just post something on Fox News and get an accurate estimate of who the next president's going to be. You probably wouldn't get you wouldn't get an accurate estimate of the next president if you looked at MSNBC. Now, it may be possible to combine those two and look at the underlying demographics of the people and do some sort of non-probability sampling and research in that area. But you can't basically treat those as probability samples. It's different. Now, when we talk about sampling bias, we're talking about the kind of things that you usually think about. So if you want to know, ask a person, are you satisfied with your job? Yes or no? And 70% of the people say yes, and based on the sample size, you're going to get plus or minus some number, say 5. So the confidence interval gives you 65 to 75. The point with that is that when you do or take a sample, you're trying to find the truth. Now, there is error in sampling. I mean, there's just random error. The graph at the top of this slide shows that if you sample 100,000 times and the mean is 100 with a standard deviation 16 and the sample size is 100 people, you're going to get random error around that point. Even though the truth is 100, when you do a study, you don't really, you don't get the truth. You don't know the truth. It's not that you can't handle the truth. It's just that you can never know what it is. And you use sampling error as a measure to measure the accuracy of your estimate, to give yourself a sense of how close to the truth you are. I want to take a moment to talk about confidence intervals because I think there's a lot of confusion around them. In this case, we're going to look at proportions. And the standard error of the proportion, so a proportion like the job satisfaction at 70%, you have P, which is the proportion. You have 1 minus P, which is, in this case, 30%. It's those people that said they were dissatisfied, so it's P times 1 minus P, divided by N. So you can see that the larger number of people you sample, the smaller this error is. let's again visit the bell curve. That's a theoretical normal distribution of all possible samples given a particularly underlying truth. So people are really, this line going down here is the truth, which you cannot know. You don't know what it is. You're doing your study to estimate it, but your study is an estimate. And here's a proportion. This is the 95th percentile, and it has a width to it. Now notice it overlaps the truth. So you know that given this particular proportion and the standard error, you have a 95% chance that your proportion and your confidence interval, rather, will overlap the truth. The confidence interval is the proportion plus or minus 1.96, which is a z-score, almost 2, approximately 2, times the standard error of the proportion. Now in this case, we have theoretically sampled or done our study 20 times, each time doing it identically to the same population. I mean, it's theoretical. And the idea is if you did it an infinite number of times, your confidence interval would overlap the truth 95% of the time. In this case, there's 20, so it overlaps in 19 and fails to overlap the truth in 1. 1 out of 20, 5%. 95% overlaps the other. What is important to notice here is that the upper and lower and upper limits of the confidence interval are not the bounds of truth. That is not what the definition of a confidence interval means. It means that if you were to theoretically sample an infinite number of times, 95% of the time your confidence interval will overlap the truth. So really this width of this bar gives you some sense of how accurate the your estimate is. So when you hear somebody say the proportion was 70% plus or minus 5, that does not mean the truth is somewhere, is bounded by 65 and 75%. The truth is the truth. It has no bounds. It can't vary somewhere between 65 and 75. The truth is the truth. Your sample confidence interval is what varies, and the narrower that plus or minus, the smaller that plus or minus number is, the more accurate, the more likely that your estimate of 70 is close to the truth. It doesn't say it's between 65 and 75. So there's probably there is general misconception on what that means when people say plus or minus 5. The other thing is we noticed before that sample size matters. Surveys are large sample studies. And the assumption in figuring this out is that you have an enumerated probability sample. You can't go on Fox News and do a web survey and say 80% of the people think Donald Trump is doing a good job. And let's say you get varying numbers of people responding to that survey. This is not the confidence interval that overlaps the truth. Now, I think you'd even be hard-pressed to say it's a representative sample of the people that hit the website of Fox News, or even that it's a representative sample of all the people that answer a Fox News survey. I mean, you're getting closer to what it is a measure of. But to say that it's a measure of the people that support Donald Trump is just not the truth. And in the same way, I mean, the argument with MSNBC is exactly the same in the other direction. It's not representative of what the truth is. So, but if you do have a probability sample, then you can see, this first tick is a sample size of looks like 52. And it gets bigger and bigger and bigger. And as it gets bigger, this is the width. This is the plus or minus 5. Only it goes to 20, 40, 60, 80 as you get close. I mean, a proportion with those kinds of numbers is pretty bad. So it tails off. Now you can see that you start to lose advantages of gain. I think it's around 700 that you get your plus or minus 3. And the thing that's interesting about that, it doesn't matter if you're looking at Donald Trump or whether you like Jeff Peanut Butter. The proportion and the standard error associated with it is the same. So if you choose to do your dissertation as a survey, realize you have to sample a fair number of people. And the other thing that's important about that is that you don't just go out if you need 700. Like, for example, in one of the studies I'll show you, it was pretty big. It's 100 questions, big latent structure. I figured I needed 700 responses. So I sampled 1,000. Now, for those people that didn't respond, I didn't go get another different person to increase my sample size to get to 700. I resampled the 1,000 people. I just kept bugging them until I got 700. That is a representative sample of a probability sample, not just going for the number. So that's one of the things we're talking about in this series of lectures is how to get that number, how to bring it up. I mean, I did a job satisfaction survey for years at Children's Hospital. Well, not too many years, but when I was not part of Children's Hospital, I did a survey. And I always had a response rate in the 70% area. But the company that did that job satisfaction before me had a 6% response rate. And that's because they didn't, and this was a professional group that actually charged a lot more than I did, but they just didn't follow design principles and they didn't bug the people. So you have to go for it when you're doing a sample. I'll be repeating this over and over again. So if you do a simple survey, simple probability random survey, you're not necessarily getting an accurate estimate of the overall prevalence. Now, there's there are different goals when you're sampling. Let's take the hospital survey. Most of the staff that I was surveying, I did not survey doctors. They're not part of the hospital employee system. Most of the workers in a hospital are nurses. Then there are a lot of custodial type people. There are secretaries. There are administrators. There are different numbers of types of people. And so you need to, if you just sample straight out probability, you're going to get mostly nurses. So you actually want to undersample the nurses. That is, not just do if 60% or 40% of the staff are nurses, you only want to maybe sample, maybe have 20% of your sample be nurses. You undersample it. And if you want to include, say, make sure that engineering is included, then maybe you sample 100% of the engineers. Specifically, you break it down into categories and you sample everybody in a small group. So you get one or two. And then when you're done with that, you decide, well, do I want the overall average? Do I in fact want an overall average, or do I want an average within each category? And maybe you even have two reports. One where you say, well, how nurses feel about things. One where you say about how does the custodial department feel about things. Or you could have just a general number with everybody. In either event, you need to weight your responses. So you look to see what the probability is that you sampled a nurse, for example, and what the proportion of people are nurses. And then those two numbers give you a weight for nursing. We're not going to go into any more detail than that in terms of weighting and sampling, but I just wanted you to know some of the things you need to take into consideration and follow up and get answers to. Another adjustment is, for example, cluster sampling. So, for example, when you want to do a survey of schools, you balance your survey demographically, school demographically, and then you go in, and again, the school doesn't answer the question. You're interested usually in either the students or the teachers. And so then you pick a school, and if it's teachers, you survey all of them. If it's students, you might want to sample the students as well. And then you can't just list all your survey responses into one big giant Excel spreadsheet and then tabulate each of the answers and come up with it. You need to adjust within schools, within these clusters. You need to adjust your variability based on the clusters. That's also pretty detailed. We're not going to get into that right now, but you need to know that you need to do some further adjustments. You can't just consider it a simple counting everybody equal and putting it into a program. It gets complicated. Another big problem type of error is non-response. Do the people who don't answer your survey, do they feel the same as the people that do? And I recall in the hospital, there was a patient survey, and I wasn't involved with this one, but basically what happened was every person that was discharged from the hospital got a survey afterwards asking how they did. how the hospital was, whether they were satisfied with their experience. Now, this particular method is not a way to find out patient satisfaction. It does have some useful features. People, if you survey everyone, if somebody had a particularly bad experience, then they will respond. Or they may respond. Not always. They'll just go someplace else, although they're not going to go to another pediatric hospital in Columbus, Ohio. But they can potentially highlight a problem that has been experienced. But you're going to get a bimodal distribution. You're going to get people who really didn't care for their experience, and you're going to get people who loved their experience. So the real purpose, I would say, I mean, it wasn't stated this way, but the real purpose of that patient survey was A, identify particular problem areas in a case-by-case type of method, not by some proportion of people, but just highlight individual problems. And second, to get marketing statements, because the people that love the experience, there's an open-ended comments, and they'll make some statement that'll go in the advertising. But it is not a method. Sending out a single follow-up mailing to people is not a valid method of determining the general satisfaction of the experience of the hospital. Even a high response rate doesn't guarantee non-bias, but it is a start, and it's what we're going to try and do, is talk about ways to boost your response rate. Another thing you could do is, for people that don't respond, you can actually go out and track them down and ask them specifically through a phone interview or a on-site interview, how do you feel about certain things? And you could do selected questions and see if their responses were similar to the responders. It's complicated. Measurement error. Now that measurement error is the kind of thing where the person, say, they think agree is disagree, or the wording is confusing, or you have a double negative in your question and they miss that. It's just your question doesn't really get at what you think it is. People answer questions from different reference points. So one of the things that you have to do when you're deciding or when you're developing your questions is you have to construct questions so that the responses are consistent. When we talk about writing questions, we're going to address these issues. We want to get consistent responses to questions. And again, we're just going to do a taste of some things about questions. You need to do a good reference literature search on question making. Or look at a good book like Dillman and find out, because I cover a lot of things and frankly I rip him off pretty liberally. But I'm telling you that I rip him off liberally and that you should go see the rest of it by getting his book. Finally, let's talk about non-probability sampling. I have installed a link here that puts you to a paper that discusses methods for addressing and using non-probability sampling. And it covers a lot of interesting things. I did once do a web survey of families of kids with a particularly onerous disability. And the way we did it was we sampled user groups, parent groups basically, support groups, and then the parents enlisted other people with kids with similar problems to fill out the survey. It's one way of getting answers within that population. It's not really probability. There still was self-selection. There still was probably bias in there, but it gives you some ideas. There are post-survey adjustments where you weight the responses based on their characteristics. So if you're you look at the demographics and then you weight according. There's another method called propensity matching that I think has promise for this. Propensity analysis is a really strong kind of design methodology. And I've given you a link here to a paper on this that started talking about it. When you can't use randomization, whether or not you're doing a survey for your dissertation, you should check out this method just for whatever your dissertation study is about. It is a solid method that has been used in medicine quite a bit, and it will help you balance your groups. If you're testing one kind of a treatment or one kind of an approach versus another, it helps you balance your sample. So basically, we have to understand that to do valid, standard, statistical methods, this requires a probability sample. You only pretend to create confidence interval and perform t-tests on unenumerated sample frames. But you are just kidding yourself, and a high-quality journal will not accept your results. Transparency in your methodology is essential to publication. You can get away with more if you are honest and humble about the approach you took. And you need to consider these coverage or these types of errors when you are writing up your results. You need to explicitly address each of them in your discussion section and how your study approached it. That transparency will get your paper published.